Today we are going to discuss derivatives of composite functions part 2. In this we will be discussing derivatives of trigonometric functions, exponential functions, and logarithmic functions. First, let us see derivatives of trigonometric functions. Trigonometric composite functions are of the form, say, sine of f of x, cos of f of x, tan of f of x, etc. So, for example, sine of x square plus 1. Here f of x is x square plus 1. This is a trigonometric composite function. Cos of log x, tan of 2x plus 5. All these are examples of trigonometric composite functions. Now, in this case, our substitution is we put u equal to f of x. And we use chain rule. Chain rule is dy by dx is equal to dy by du into du by dx. So let us take some example. Consider the function y is equal to sine of x square plus 5x minus 3. Find dy by dx. Let us see how we can differentiate this function. This is of the form y is equal to sine of f of x. Our f of x is x square plus 5x minus 3. Whenever the function is of the form y is equal to sine of f of x, our substitution is u equal to f of x. So here we put u equal to x square plus 5x minus 3. Then what happens to our y? Then our y becomes y equal to sine u. So y is a function of u and u is a function of x. Since u is a function of x, we can differentiate u with respect to x and find du by dx. Du by dx equal to d by dx of x square plus 5x minus 3, that is equal to d by dx of x square plus 5 into d by dx of x minus d by dx of 3. d by dx of x square is 2x and d by dx of x is 1. Derivative of a constant is 0. So this we get it as 2x plus 5. Next, y is equal to sine u. So y is a function of u and we can differentiate y with respect to u. That is, we can find dy by du. That is d by du of sine u. You put the value of y as sine u here. So this is d by du of sine u. Now we know that d by dx of sine x is cos x. So d by du of sine u is equal to cos u. Now apply the chain rule. Dy by dx equal to dy by du into du by dx. That is equal to cos u into du by dx is equal to 2x plus 5. So this is equal to 2x plus 5 into cos of our u is, finally don't forget to substitute the value of u. So our u is equal to x square plus cos of x square plus 5x minus 3. So this is our dy by dx. Let us take another example. Consider the function y is equal to cos of x into e raised to x. So this is of the form y is equal to cos of f of x. This is of the form y equal to cos of f of x. Now, whenever it is of the form cos of f of x, our substitution is u equal to f of x. And our f of x is x into e raised to x. So our u equal to x into e raised to x. So y becomes cos u. Now, we differentiate u with respect to x. That is, we find du by dx. That is equal to d by dx of x into e raised to x. Now, to differentiate this is a product of two functions, x into e raised to x. So, we have to use the product rule here. What is the product rule? We have d by dx of u into v equal to u into d by dx of v plus v into d by dx of u. So d by dx of x into e raised to x is x into d by dx of e raised to x plus e raised to x into d by dx of x. That is equal to x into d by dx of e raised to x is e raised to x itself, and d by dx of x is 1. We can take e raised to x as a common factor, and inside the bracket you will get it as x plus 1. So our du by dx is e raised to x into x plus 1. Now y is equal to cos u. So we can differentiate y with respect to u and find dy by du. Now dy by du is d by du of cos u. D by dx of cos x is minus sin x. So d by du of cos u is minus sin u. So dy by dx equal to dy by du into du by dx. That is equal to dy by du is equal to minus sin u, and du by dx equal to e raised to x into x plus 1. Finally, substitute the value of u. Our u is x into e raised to x. So it is minus sin of x into e raised to x into e raised to x into x plus 1. So this is our dy by dx in this case. Now, there is two important results that we can get from here. Look at the function y is equal to sin mx. Here, if we put u equal to mx, then y is equal to sin u. Now du by dx equal to d by dx of mx, that is equal to m into d by dx of x, that is m into 1, that is equal to m, and dy by du equal to d by du of sin u, that is equal to cos u. So apply the chain rule. Dy by dx equal to dy by du into du by dx, that is equal to cos u into du by dx is equal to m. This we can write it as m into cos of u is mx. So we get an important result, d by dx of sin mx equal to m into cos mx. So we can directly write using this result, say d by dx of sine 2x. 2x means at the place of m we have 2. So this becomes 2 into cos 2x. Say if it is d by dx of sine 3x, then at the place of m we have 3, so the answer becomes 3 cos 3x. So this again we remember it as a standard result, d by dx of sine mx equal to m into cos mx. Same way, if it is y equal to cos mx, then we put u equal to mx, so y equal to cos u. So as before, du by dx equal to d by dx of mx, that is m into d by dx of x, that is m into 1 equal to m, and dy by du equal to d by du of cos u, that is equal to minus sin u. So we have dy by dx equal to dy by du into du by dx, that is equal to minus sin u into m, that is equal to minus m into sine of u is mx, so it is minus m into sine mx. That is, our result is d by dx of cos mx equal to minus m sine mx. This again we can use it as a standard result, and we can write d by dx of say cos 5x. Your m is 5 here, so it becomes minus 5 sine 5x. Now, y is equal to sine of x square plus 1. This is of the form y is equal to sine of f of x. There is a direct formula also to find derivatives of trigonometric functions. See, we have d by dx of sine x is equal to cos x. So the direct formula is d by dx of sine f of x. You can write it as cos of f of x into d by dx of f of x. Similarly, d by dx of cos f of x, it will be minus sine f of x into d by dx of f of x. See, please remember, d by dx of cos x is minus sine x. So d by dx of cos of f of x becomes, it is minus sine f of x into, and we always multiply it with derivative of f of x. Say, look at this example. So this above function, d by dx of sine of x square plus 1. Now using the direct formula, see how we can do it. It is of the form sine of f of x. So d by dx of sine of f of x is cos of f of x into d by dx of f of x. So this is equal to cos of x square plus 1 into d by dx of x square plus 1. That is equal to cos of x square plus 1 into d by dx of x square plus 1 is d by dx of x square plus d by dx of 1. That is equal to cos of x square plus 1 into d by dx of x square is 2x and d by dx of 1 is 0. So it is equal to 2x into cos of x square plus 1. Now let us see how we can find derivatives of exponential functions. derivatives of exponential functions are of the form, say, e raised to f of x, a raised to f of x, etc. In this case, again, the substitution is u equal to f of x. Let us take one example. If y equal to e raised to 3x square plus 5x minus 2, find dy by dx. So, our f of x is 3x square plus 5x minus 2. So, we use the substitution u equal to 3x square plus 5x minus 2. So, our y is equal to e raised to u. So, first we find du by dx, that is d by dx of 3x square plus 5x minus 2. This we can write it as 3 into d by dx of x square plus 5 into d by dx of x minus d by dx of 2. d by dx of x square is 2x, d by dx of x is 1 and d by dx of 2 is 0. So it is 3 into 2x plus 5 into 1 minus 0, that is 6x plus 5. This is our du by dx. Next we find dy by du, that is d by du of e raised to u. Now d by dx of e raised to x is e raised to x itself. So d by du of e raised to u is e raised to u itself. So apply the chain rule. Dy by dx equal to dy by du into du by dx. That is e raised to u into du by dx is 6x plus 5. Finally, substitute the value of u. Our u is 3x square plus 5x minus 2. So it is e raised to 3x square plus 5x minus 2 into 6x plus 5. That is our dy by dx. Now let us consider the case of y equal to e raised to mx, a particular case. So here we put u equal to mx. Remember, m is a constant here. So y is equal to e raised to u. dy by du equal to d by du of e raised to u, that is e raised to u itself, and du by dx equal to d by dx of mx, that is m into d by dx of x, that is m into 1 equal to m. So dy by dx equal to dy by du into du by dx, that is equal to e raised to u into m, that is m into e raised to mx. This is again used as a standard result, that is we have d by dx of e raised to mx is equal to m into e raised to mx. So using this we can write d by dx of e raised to 3x equal to 3 into e raised to 3x. So these three results, d by dx of sine mx equal to m